Okay, perfect. Now I'm gonna share website, share. Okay, I'm gonna sign up. Okay. So I have to do this now, I guess. Password. Okay. Do you see the board, guys?
Yes.
Yes.
Okay, perfect. Thank you. Thank you. Okay, perfect. Just make sure, because this is the first time using the iPad, Zoom on the iPad. Okay, so I guess we're gonna start a new section, section 1.8. So this section is gonna be in the test, all right? And it's a kind of a short section, and probably you're gonna also start the chapter 2. All right, so this section is gonna be in the test. Okay, so this is last section in the chapter 1, section 1.8. And so it's about inverse functions. Okay, so what's the inverse of a function? For numbers, if you have like, I don't know, like 3, then the reciprocal would be 1/3, and 3 times 1/3 would be 1, right? So we have like a similar, similar notion for functions, and that's what we call actually inverse functions. It's sort of, it's not really a reciprocal of the function, but it's kind of similar, right? So so here's the definition of the inverse function. So definition. So the inverse of a function f of x is a function g of x, says that. So here's the definition. So the condition is the following: you need f of g of x so f composed with g of x to be equal to g composed with f of x to be equal to x. Okay. And so just a remark here. So this is a definition of the inverse. So the inverse of the function f is this the function function g says that this f composed with g is equal to g composed with f is equal to x. So this inverse function, this g of x, it's not the reciprocal of f. It's not 1 over f. So this is remark. So this the inverse function g of f is not, it's not 1 over f. So the inverse function g of x. So the inverse function g of x, is not. So this is not g of x is, this is not 1 over f of x. Right. So, well, before the examples, let me just introduce a notation for the inverse. So actually, if g is the inverse of f, then we write g so G would be F to the power -1. So notation. So the inverse of f of x is denoted by, so this G is, so it's F to the power -1. So that's how we denote the inverse. Okay, so F to the power -1. Right, so when you see F, so when you see power -1, F to the power -1, that means that's the inverse of F. So this is the inverse of F inverse, right? F inverse. Right. So let me just do an example. Okay. So let's say f of x is 4x minus 7. All right, that's my function f, and the function g, let's say g of x is x plus 7, the whole thing divided by 4. Okay, so I have these two functions, f and g, and I want to check if g is the inverse of f. So let's check if g of x is the inverse of f of x. And so what we have to do, guys, so there are two steps. We have to check that f composed with g of x is equal to x, and g composed with f of x is equal to x. Okay, so so there are two steps. So first step is, what you want to do first is, so step one, so we need to check if f composed with g of x is equal to x, right? So let's see if this is true. So my so you wanna compute f composed with g, right, of x. So again, this is by definition f of g of x. All right. So let me just write down f of x, and then I'm gonna substitute x by g of x. So my f of x is 4x minus 7. Okay, so as you can see, guys, I have an x in here. Okay, so I need to replace x by this g of x. Okay, so it's gonna be, well, I have 4. Here's 4, and then instead of x, we're gonna have g of x. So here's my g of x. So it's x plus 7 over the whole thing over 4. Right? This is multiplication here. All right, and then we have minus 7. It's minus 7. Okay, so let's simplify this. So we have, so this is f composed with g. So it's 4. You know, you can write 4 like 4 over 1, right? I mean, this 4 here, I can write like 4 over 1. And then I have times multiplication, right? And have x plus 7 divided by 4. And then I have like minus 7. I mean, it's a good idea, guys. I mean, if you have like a fraction and you have like a whole number, like here we have a 4, right? That's a whole number, and you have this fraction x plus 7 over 4, then it's a good idea, you know, to divide the 4 by 1. So that will be it will be a fraction now, right? So now, so that will be equal to you know, so multiplication of fractions, you multiply straight across, so 4 times x plus 7, right, over 1 times 4, that's 4, so this is multiplication here, and then minus 7, right? So then because I have now multiplication in the top, I can cancel out the 4, so this 4 here cancel out, right? And of course, when you cancel out the 4 in the denominator, it's not, you are left with 1. It's not 0 in the denominator because this is like 4 times 1, right? So it's like x plus 7 over 1, which is x plus 7. So, so then f, sorry, then f composed with g. So then f, so f composed with g of x, it's so it's going to be x plus 7 over 1, so it's x plus 7, and then there's this minus 7, right? And then the 7 cancel out, of course, 7 minus 7, and so the answer would be just x. All right, so you see I got x, right? That's exactly the definition. So f composed with g. So f composed with g of x is equal to x. And that's exactly the first part of the definition of the inverse. I mean, if you check again, definition of inverse function, guys. So you see here, I need my f composed with g to be equal to x, right? So that's the first part. Then the second part, we have to check that, you know, this g composed with f would be equal to x, right? So you see there are like two parts in this definition. So you need f composed with g to be equal to x, and then we need to check, so in the step 2, we need to check that g composed with f is equal to x. So now the step 2, so in this step 2, we're gonna check, if g composed with f of x is equal to x. So let me just say, remark, guys, here. I mean, if you don't get x, if I don't get this x, then I can stop, you know, and I can conclude that the g of x is not the inverse of f. Okay, so if you don't get x in the first step, then you don't have to do the step 2. You can just say that this g is not the inverse of f, right? So if you get x in the first step, then you have to continue with the step 2. You have to check that g composed with f is equal to x. So now let's compute this thing here. So this is, you know, you want to compute g composed with f of x. So this is by definition g of f of x. Again, I can write down here g of x. So g of x, it's x plus 7 over 4. So it's x. So this is x plus 7 over 4. So there's an x in here. You see this x here? This one here. All right. So I have to substitute x with f of x. So here, so it's going to be f of x. You know, f of x plus 7 over 4. Okay. Well, so let's compute this thing here. So this is g composed with f of x. So we said it's f of x plus 7. F of x is, you know, here it's 4x minus 7. So we have 4x minus 7. So this is 4x minus 7. That's my f of x. And then I have plus 7, right? And then I have, you know, see this plus 7 here, and then I have to divide by this 4 here. All right? So now you can see I can cancel out the 7 minus 7 plus 7. So then it would be just 4x over 4, right? So then I can cancel out the 4, and then I get x. So my G composed with f of x is equal to x. Okay, so in both steps, step 1 and the step 2, I got x. So then I can, the conclusion is that this function G is the inverse of f. So the conclusion. So this G of x, which is x plus 7 over 4, is the inverse function of f. The inverse function of f of x, which is f of x. It's the 4x minus 7, right? So this G, which is x plus 7 over 4, is the inverse function of f. So that's f inverse. So so then f. So this G of x is equal to the inverse of f. So f inverse. So that's again, the notation is with the power -1. This power -1 means the inverse. So the inverse of f is equal to this x plus 7 over 4, right? And again, guys, if you don't get x in the first step or in the second step, then you can say that this function g is not the inverse, all right? Well, is there any question first about this example? And again, you see, guys, I mean, this g of x, this is not 1 over f. I mean, if it's not the reciprocal of f, right? This is, I mean, you can see this, this g of x, which is x plus 7 over 4. This is not equal. This is not 1 over f, which is the 4x minus 7, right? This is my 1 over f. Okay, so this is not equal. So this function g, which is the inverse function of f, it's not the reciprocal of f. It's not just like 1 over f, right? So it's much more complicated than that, all right? And I mean, we're gonna see in a couple of minutes how we find this the inverse function, right? But first, is there any question about this definition? So whenever you have to check if a function is the inverse of another function, so then there are basically 2 steps to do. You have to, in the first step, you have to check that this f composed, you see here, that this f composed with g is x, is equal to x. And the same in the step 2, you have to check that g composed with f is equal to x. Okay, so, and again, if it's not equal to x in the step 1 or in the step 2, then this function wouldn't be the inverse. Okay. Well, so let me give you an example where it's not the inverse, all right? So this is example 1. So this is first example 1. Okay, so let's have another example. Again, guys, please feel free to ask questions. Yes.
Please, I want to copy the remark.
Oh, sure. Here, sure. Okay, so here's another example. So example number 2. So this is example number 2. So let's say f of x is, let's say 2x plus 5. All right, and here's a g of x, and let's say g of x is let's say it's, let's say x minus 2 over 6, all right? So, and the question, of course, is to check or determine if whether G is the inverse of, determine whether G is the inverse of F, whether G of X is the inverse of F of X. Okay. Well, so let's see. Again, we have 2 steps. So first step, okay, so we have, again, we have to check if F composed with G of X is equal to X. Okay, so I'm going to write down here F composed with G of X, and that's by definition F of G of X, of course, and I'm going to write down here F of X. So F of X is supposed to be 2x, 2x plus 5, 2x plus 5, right? That's my F. Now, F composed with G, so it's going to be 2 times G of X. Here's my G of X, 2 times G of X, and then there is a plus 5. All right. So let's compute this thing here. So this is, so again, F of composed with the G of X. So 2 times G, so it's 2 times the X minus 2 over 6, right? That's my G of X. And then I have a plus 5. And then there's this plus 5 here, right? All right, so 2 times X minus 2 over 6. Again, so this 2 here, it's a whole number. And I'm gonna divide the 2 by 1. So now it looks like a fraction, right? So the 2 is in the top and 1 in the denominator, right? So now I just multiply straight across here. So this is, so this is F composed with the G of X. So it's just 2 times X minus 2 over 6. And then there's this plus 5 here, right? So, well, so that would be equal to, well, I mean, there's 2 over 6, right? So you can reduce, so, here I can, this is 2, sorry. So I can reduce here 6, I can divide it by 2, right? So that would be, so F composed with G of X. So that would be X minus 2 over 3, right? So I just reduced, my 2 over 6. So that would be 1/3, right? So it's going to be 3 in the denominator. And then I have this plus 5, of course. Right? Okay, so now done with the simplification. So here I can just, I have only one denominator. So then, I mean, one term in the denominator. So then I can split, this fraction into 2 fractions. So this is like F composed with G of X. So that'll be like X over 3. So I'm going to split it into 2 fractions, X over 3 minus, and then 2/3. All right, and then there's plus 5 here. All right, and so this minus 2/3 plus 5, you can make this 5 as fraction. So you can divide by 1. So that's 5 over 1. So minus 2/3 plus 5 over 1. Then you're going to need the common denominator. So here I need to multiply by 3. And here you're supposed to multiply by 1. Right? So, so that would be f composed with g of x equal to x over 3 minus 2 times 1, that's 2 over 3, and then plus, and then 5 times 3, that's 15, and 1 times 3, it's 3. All right, so now you see I have a common denominator, right? Minus 2/3 plus 15 over 3. So I can subtract, the top. So it's like minus 2 plus 15. That's plus 13. So we're gonna have f composed with g of x. So it's gonna be x over 3. So minus 2/3 plus the 15 over 3. So we can subtract the top. So that's minus 2 plus 15. So that's plus 13. And we keep, of course, the common denominator, which is 3. So it's x over 3 plus 13 over 3. All right. So I'm done with the simplification, of course, here. This is obviously not equal. So this is not equal to x, right? This is not equal to x. So if it's not equal to x, then you are done. And so the conclusion is that g of x is not the inverse of f of x. So this g of x is not the inverse of f of x. And because I didn't get x, right? If I get x, then I have, to move to the step number 2, I have to check that g composed with f is equal to x. Right? But here, of course, this is not x, so I can stop here and I can say that my g is not the inverse of f. Right? So any question, guys, about these two examples? So anyway, all you have to keep in mind here first is that so this notion of inverse function. So this the inverse, it's not the reciprocal of the function f. And we'll see later how to find actually the inverse function, right? Okay, so if there are no questions, guys, so let me give you a couple of functions, and then you have to determine whether the g is the inverse of f, right? So exercise.
Professor.
Yes.
My question is the x. It can be a value or how to determine the x, or it has to be like x. I mean,
no, it has to be x. It has to be exactly x. I mean, it has to be x, just x by itself.
X by itself.
Yeah.
Okay.
Mm-hmm.
I hope it was like it could be like a number, a variable.
No. It has to be x, just x by itself. I mean.
Okay.
Mm-hmm.
Thank you.
Right. So, okay. So, exercise here. So you have to determine, guys, whether g is the inverse of f. Determine if g of x is the inverse of f of x. Right. So. 1, 2, and number 3. Okay, so number 1. So you have f of x. It's 5x minus 9, and g of x, it's x plus 9 over 4. Right. Number 2, f of x, it's the third root of x minus 4. right? And g of x is x cubed plus 4, right? Number 3, f of x is 4x plus 2, and g of x, it's okay, let me change this last one here. Let's see. I'm gonna use fraction for f. So let's say here f of x is 4 over x plus 9, and g of x, it's 4 over x minus 9. All right. Okay, guys. So I'm gonna give you 5-10 minutes to check if the function g is the inverse of f. So any guess for number one? Is G the inverse of F?
It is.
Yes, yeah, it is. Mhm. So let me just say, guys, here, when you have a third root means like power, it's like exponent 1/3, all right? When you have a third root, so it's like power or exponent 1/3. And what about number two?
Hold on. I'm still finishing it.
Okay.
Is number two as well?
Yep.
Also the inverse.
Yeah, that's the inverse, yes. So just be careful on the number 3, right? I mean, you know, I mean, you know, the fractions. Okay.
Number 3
So
is not the inverse?
you're saying it's not?
Yeah.
I think it's gonna be also it's gonna be the inverse.
Oh shit, okay, yeah, my bad. I
Or,
did not see the +9 on f of x. Oops.
yeah, there's this +9. Yeah. So yeah. Okay. So well, let me just probably start with the number 1. It's kind of similar to the example we had. So for number 1, you have so in the step 1, so we're gonna compute f composed with g, right? So again, that's f of g of x. My f of x, it's actually 5x minus 9, right? So here's my x in here. So now I'm going to substitute x by g of x. So it's going to be 5, and then, you know, times, and then it's going to be g of x. So that's x plus 9 over 5. And then there's this minus 9. All right. So again, guys, you have this 5 in the top here. I can divide by 1. And here it's a multiplication. So actually this 5 here and this 5 here, they're gonna cancel out, right? Because you have a 5 in the top and 5 in the denominator. So they cancel out. And then your, you know, your f composed with the g of x is gonna be, so we are left with 1 in the bottom. So it's x plus 9 over 1, which is x plus 9. And then there's minus 9, right? So, and then again, this 9 here cancel out, so it's gonna be x. Okay, which is good news, right? So then you can move to the next step. So step number 2, step. So now I'm gonna compute, you know, g composed with f. So now I'm gonna compute G composed with f of x. And again, this is G of f of x. So I'm gonna write down my G here. So my G is, x plus 9 over 5. So here's my x, right? So I'm gonna substitute x by f of x. So it's gonna be, so my f of x, of course, it's 5x minus 9. So it's gonna be 5x minus 9. And there's plus 9. So here's plus 9. And then the whole thing, of course, divided by 5. Right, so I just substitute x by f of x. Now minus 9 plus 9. So 9 cancel out. So it's just 5x over 5. And so then you can see, then G composed with f is going to be x, right? So it's 5x over x. This 5 here cancel out. So this is just x. Okay, so in both steps, both step 1 and step 2, we got x, just x by itself. So so then this G is the inverse of f. So G of x is equal to f inverse. So G is the inverse of f. Right? So any question about number 1? All right. So number 2, we have this third root, and we have a cube. So let's see how it works. So for number 2, again, step 1. So again, I'm gonna compute f composed with G of x. So again, that's f of G of x. My f of x is third root of x minus 4. So it's third root. This is a third root of x minus 4. So we do have an x in here. Here's my x. All right. So so this f of G of x is going to be third root of my G minus 4. So my G is my G of x is x cubed plus 4. So my G of x, it's x cubed plus 4. That's my G of x. And then I have minus 4. So and then I have this minus 4. Okay. So plus 4, minus 4, both, this is really important. So both the minus 4 and the plus 4 and the minus 4, both are under the square root. So that's why I can cancel out this plus 4 and minus 4, because both are under the square root. So now I have, I have composed G of x. So now I have just third root of x cubed. And again, guys, third root means, so that's like x cubed to the power 1/3. Okay. And, if you have, so I'm going to apply the power rule. So let me just remind you of the power rule. If you have like, so the power rule. So if you have like x to the a, then to the b, that's x to the a times b. All right. So I have to multiply the power. So this is like 3 times 1/3. So my f of G of x, it's actually x to the 3 times 1/3, and 3 times 1/3, of course, is going to be 1, right? So that's x to the power 1, right? Because 3 cancel out, so x power 1, and x power 1 is just x. It's just x. All right. Okay, so then I can move to the step 2 because it's equal to x. So I can move to I can hope that this G is the inverse of f. So I can move to the next step. So for the step 2, So in step 2, of course, we're gonna compute G composed with f of x, right? It's G of f of x, right? And my G, it's actually, it's x cubed plus 4, right? So I'm gonna substitute this x, this one here, with f of x. So f of x is third root of x minus 4, right? That's my f of x. And then I have this power, so it's power 3 cubed. So this is power 3, all right? And then there's a plus 4, and then there's plus 4. All right, so again, I can write this third root as 1/3 power 1 exponent 1/3. So this is, G composed with f of x. It's like x minus 4 to the power 1/3, and then that's my third root, and then I have a cube, right? And then I have a cube, and then there's plus 4. Okay, and again, so if you apply the power rule, so it's 1/3 times 3. So this 1/3 here times 3 cancel out, right? It's 3 times 1/3. It's going to be 1. So it's going to be just this G of f of x is going to be just x minus 4, right?
Hey, Professor,
Again,
but
yes. Yeah.
why wouldn't just the cube root just cancel out with the cube square? Not cube square.
The cube square.
Hey,
You mean the third root?
Yeah, the third root. Sorry.
Yeah, that's what I wrote. Actually, here I wrote third root, but the third root means power 1/3.
Yeah.
It's the same thing. Yeah. Of course, they cancel out the third root of the cube. Yeah, sure.
Okay.
I just rewrite
Simplified it?
I rewrote the third root as the power 1/3. Yeah.
Okay.
And then there's plus 4, and then this 4 here cancel out, so it's just equal to x. And okay, so I got x both cases, both steps. So of course, then the conclusion. Again, my G of x, G is the inverse of f of x. Right, so the inverse of f of x. Right, so so G of x is f to the power -1 of x. Right. Yeah. So this is for number 2. For the last one, number 3. Well, first, is there any question, guys, about this third root? This example.
Just want to.
Excuse me.
I want to copy it.
Oh yeah, sure, no problem. Yeah, of course. All right. So okay, so let me then solve the problem number 3 here. So for number 3, so step 1. So I'm gonna write f. So we have to compute f composed with g of x. Again, that's f of g of x. F of x, I think f of x, it's 4 over x plus 9. If I'm not mistaken, this is 4 over x plus 9. So there's an x in here. You see this one here, green x. So I'm gonna substitute that x with g of x. So it's gonna be 4 over, and now just be careful. So g of x, it's a fraction, right? G of x is, I think it's x plus, no, sorry. It's 4 over x minus 9. So it's gonna be here, it's gonna be 4 over x minus 9, right? And then there is a plus 9. Don't forget the plus 9 because, of course, I mean, it makes a huge difference if there's no plus 9 there. Anyway, so first I have this 4 over x minus 9. So I mean, this is division of fractions. The 4 in the top, I can make it look like a fraction. So I have only I can just you know, divide here by 1. This 4 in the top. So 4 over 1, of course, is just 4. It doesn't change anything. So this is division of, you know, 2 fractions, and so all you have to do now is to flip you know, the denominator. So it's 4 over 1 times, and then you flip the x minus 9 over 4. So x minus 9 over 4. Right, and so you flip this one, and then there's plus 9, and then there's the plus 9, of course, here. All right, now, so I have to multiply these 2 fractions. So you multiply straight across. There's a 4 in the top, there's a 4 in the denominator. So this 4 here cancel out with this 4. And again, I can cancel out because this is a multiplication, right? So I can cancel out the 4, and then, so it's gonna be just, so this f composed with g of x, so it's gonna be just x minus 9 over 1, which is just, I mean, any number over 1 would be the same number. So x minus 9, and then there's plus 9, of course. It's plus 9. So this is canceled out. So it's just x. All right, so if it's x, then again, I can move to the next step, the step 2. So step 2. And now I have to compute g composed with f. So g first and then f. Okay, so g first of f of x. So again, g is, you know, 4 over x minus 9. So here's my x with the green. All right, so this is 4 over, so the x now is going to be f. So my f is, you know, 4x plus 9. That's my f, right? And then don't forget there's a minus 9. You see this here? This is minus 9 here. So here's my minus 9. So this is minus 9 here. All right, so, and the denominator, I can cancel out the 9, right? So it's now, so my g of f of x, it's 4 in the top, and then 4 over x in the denominator. All right, so again, I can make the 4 in the top look like a fraction, so it's 4 over 1, and then I can, you know, flip the denominator, so it's 4 times 1 times x over 4, right? And of course, this is multiplication, so I can cancel out the 4, and then I'm left with x over 1, and of course, x over 1. Any number over 1 is going to be just the same number, so it's going to be x. So that's equal to x. So this is x. Right. And okay, so in both steps, I got x. So conclusion is that this g is the inverse of f. G of x is the inverse. So f inverse. Okay. I mean, actually, it's I don't know why, but I mean, it's a coincidence here. Like the 3 examples, all of them, the g is the inverse of f. But it's just a coincidence here. I don't know why. I forgot probably to include an example where it's not the inverse. Anyway, well, first, is there any question, guys, about this exercise? All right, so that's the notion of inverse. Well, there's something interesting about this inverse function. So let me just give an example to see what's interesting with this inverse function. So let's say we have you know, we check that, let's say if f of x is 4x minus 7, right? Actually, we check that if g is x plus 7 over 4, okay, then actually this g is the inverse of f. So that was our first example, I think. So we checked. So we already checked that this the g is the inverse. The g of x is the inverse of f. All right. That was our first example, right? Okay, so what's interesting about this inverse is the following. So let me just take make a table of value, some values of function f. So you know, so let's say here's my x, and here's my f of x. For example, if x is 1, okay, again, f of x is, you know, 4x minus 7, right? So what would be f of 1? You know, it's just 4 times 1 minus 7. So it's negative 3, right? So f of 1, oops. So f of 1 would be 4 times 1 minus 7. So the answer would be negative 3. Right? Let's take another value. So let's say x is 0. If x is 0, then f of 0, 4 times 0 is 0 minus 7. So that will be negative 7. Right? And let's say if x is 2, then f of 2, that's 4 times 2 minus 7. So that's 8 times minus 7. That's equal to 1, right? Now, so what I'm going to do, I'm going to interchange. So I'm going to make a table of values of the g. And so, so now, this is a different table, but with the function g instead of f. Okay. So what I'm going to do, let's say, for example, let's say x is negative 3. All right. So what's the g of negative 3? Well, you know, negative 3 plus 7 over 4. So that would be 4 over 4. That would be equal to 1, right? So you see here, my point, guys, is, you know, for f, I got 1 here. If x is 1, then f of 1 is negative 3, right? Now, you see what happens with the g. If you interchange, so if you switch the x and the y, so for example, if your x is negative 3, then g of negative 3 is going to be 1, right? So it's like you interchange the x with the y, right? So if x is 1, f of 1, we said it's negative 3, right? But for the function of g, if x is negative 3, then the output would be 1. So it's like you interchange your x with your y. Yes, that's not, yeah, that's like, yeah, absolutely, Carrie. That's like an easier way to do it, yes. Now if you pick, let's say, x, let's say x is negative 7, okay? You see here, for my f, when I have 0, when my x is 0, f of 0 is negative 7, all right? Now, if my x is negative 7, so my guess would be, you know, you interchange like the x and y. So my guess is that g of negative 7 is going to be 0. And let's see. So g of negative 7, it's negative 7 plus 7, right? It's x plus 7 over 4. So it's negative 7 plus 7 over 4. That's 0 over 4. And 0 over any non-zero number, it's 0. So I got 0. So you see here, guys, for f, when my x is, for f, when my x is 0, I got negative 7. All right. Now for g, if you if your x is negative 7, then g of negative 7 is 0. All right. So the idea is the following. Actually, so what I'm saying is, so the idea is, so if let's say, the idea is, so if f of 1 is -3, then the inverse, then g of -3, or I mean f inverse of -3, okay, that will be equal to 1. So or if f of 0 is -7, then f inverse of -7 is 0, right? So you interchange the x and the y, right? So you see, this is very interesting with this inverse function. So you interchange this x and y values. Anyway, so we're gonna use this actually to find. So this is. So we're gonna use this to find the inverse of the function f. So we're gonna use. Oops. So we're gonna use. So we're gonna use this to find the inverse, the inverse function. The inverse function, right? So again, the idea is you interchange the x and the input x and the output y, the x and y values. Okay. Okay, so how do we find the inverse using this this remark, or using this observation? Okay, so now the question is, so how do we find the inverse? Okay, so what I'm gonna do, guys, I'm gonna make a table with two columns. Okay, in the first column, I'm gonna put an example, and the second column, I'm gonna write down the step. Okay, so okay, so here's my so here's an example. This is my example. And here I'm gonna put the steps. Okay, so let's say my example is, just take a random function f of x equal to, let's say 2x minus 7. All right. So again, this is how we find the inverse. So I'm gonna find the inverse of f. Right. So first step 1, I'm gonna just replace f of x by y. F of x by y. Okay. So like here, you see this f of x here. Now it's gonna be y. So y is equal to 2x minus 7. Right. This is like the first step. Just replace f of x or g of x or h of x or whatever by y. Okay. And now, as I said, I'm going to use this observation that, for the inverse, what we do is we interchange the x and y. So I'm going to interchange x and y in the second step. So in the step number 2, I'm going to interchange x and y. All right. So when I say interchange x and y, it means y becomes x. So this y here, becomes x, and so that's is equal to, and x becomes y. All right, so becomes y. So it's picking the same color, all right? Minus 7. Okay. So interchange x and y, and now and then the last step is to solve for y. Okay. So in the last step, you solve for y. Solve for y. Okay, you need to solve for y. Okay. So let's solve for y. You know, so this is x equals to 2y minus 7. Let's add plus 7 both sides. So this is x plus 7 equals to 2y. All right. And then I'm going to divide both sides by 2. The whole thing here, the whole left side by 2. So my 2 here cancel out. So then y, so y is equal to x plus 7 over 2. And my claim is that this function y, this y here, that's the inverse function. So, so the conclusion here is that this x plus 7 over 2 is the inverse function. All right, so the inverse function of f is equal to this x plus 7 over 2. All right, so that's my inverse function. All right, is the inverse of f of x. This is so this is the inverse of f of x. So you see, guys, so the steps how we find this inverse function, and again we are using this idea is that you know, you can somehow interchange this x and y values, right? And so that's how we find the inverse function. Well, but there is actually there's one problem with this, you know, this the steps. You know, the last step, you need to solve for y. The thing is, sometimes, you know, you cannot always solve for y. Okay, so for example, so here, so this is a remark. Oops. So remark. So we cannot always solve for y. Okay, that's a kind of a bad news. We cannot always solve for y. Okay. For example, I'm a very basic, very simple example. I'm gonna just take f of x. Let's say f of x is equal to constant, right? Just f of x is equal to some number, constant. So let's say it's equal to 2. All right. So this is a constant function. It's not. I mean, the output is always the same. The output is 2. So it's a constant function. So this is constant function. The output is always the same, which is 2. Okay, so if you follow the same steps, I mean, if you want to find the inverse of this function, which is function 2, you know, the output is always 2. Then let's see what happens. Okay, so here's my table again. Here is my f of x is equal to 2. So first we said just replace f of x by y. That's always doable. I can just, you know, replace my f of x by y. So y is equal to 2. Now I need to interchange, you know, x and y. So x becomes y, y becomes x. Well, here there's no x. I have y. So this y here, this y here becomes x. So it's going to be now x. All right, so it's going to be x equals to 2. right? And again, there is no x here, right? So just my y, so my y becomes x. Now I'm supposed to solve for y, right? Now I'm supposed to, solve for y, but there's no y, so I cannot solve for y. So I'm supposed to solve for y, but that's not possible. This is not possible because, there's no y, right? There's no y here. Okay, so we cannot solve for y. So this constant, very basic function here doesn't have an inverse. So f of x equal to 2 do not have an inverse. Okay, so f of x equal to 2 do not or does not have an inverse. So sometimes there's a problem with this step, the last step. When you solve for y, sometimes you cannot solve for y, right? So so it says that some functions do not have some functions do not have an inverse, all right? So those are the steps. So if you want to find the inverse of a function f, then you need to follow these steps. So here's an exercise. So we need to find exercise. So we need to find the inverse of the function f. So find, if possible, of course, find, again, sometimes it's not possible to find the inverse, but find the inverse of f of x, of course, when it's possible. All right, so first function, so 1, let's say 2. So I'm just gonna keep the steps for you here. So 2 and then 3. So first function f of x is 3x plus 4. Next function, we have f of x equal to 2 over x minus 1. Okay, and third function, f of x, it's 5 minus x over x plus 1. All right, so please, guys, find the inverse of this function f. All right, and remember the steps is they are here. First, replace f by y, interchange x and y, and then and then solve for y when it's possible, of course, and then solve for y. So let me know, please let me know, guys, if you have any question about the steps. So when you solve for, yeah, it was just the last step when you solve for y, I mean, just be careful because sometimes it's not obvious. I mean, we'll see when number, especially with number, I guess number 3, right?
Hey, Professor, for number 2, I'm a little stuck when you have to solve for y. So far, I have like x plus 1 equals
Yes,
2 over y. I
yes.
was thinking like the first thing I probably would have done was just like multiply by 2, like, but I'm pretty sure that's wrong.
Well, so
Gonna
you want
get
to move
the
the,
division.
the y to the top, right? I mean, the
Yeah,
way to do it is this is like because it's a fraction. So what we can do is we can flip both sides. So uh, so I guess so what I'm saying is so I guess at some point we have 2. Oops. So you have like 2 over y, and then you have like x plus 1, right?
yeah.
Oops, x plus 1, right? So what you can do is you can, the left side is a fraction, so you can make the right side look like a fraction. So you can just divide here by 1, all right? And then the thing is, you can flip flip both fractions. So so then like y over 2 would be equal to 1 over x plus 1. So you see, you flip both fractions,
Mm.
and it's going to be So it's still equal. So when you flip, it's both sides, it's going to be still equal. So yeah. So then, of course, there's this 2 here in the denominator. I mean, to get rid of this 2, all you have to do is to multiply by 2, right? Both sides here. So then, you know, you can cancel out the 2. So anyway, so what I'm saying is, if you have, like in the equation, you have fractions, and you want to move like your y to the top, you can just flip both sides.
Okay.
Okay. It's, you know, it's like saying, if you have like, let's say you have 2/4 equal to half, right? If you flip 4/2, it's going to be equal to 2/1. So you see, it's, if you flip both the fractions, it'll still be equal.
Mm.
So I guess probably today I won't have time to start chapter 2. I mean, we're almost done with this section in the universe. Probably there's one more remark. But anyway, so yeah. So tomorrow I will post homework number 5, and it's gonna be probably about the inverse function. And I guess, again, guys, so we won't meet next Monday. So I will see you probably next Wednesday. And the next Wednesday, I will probably start chapter 2. And I will let you know exactly what will be the material for the test. But I think the material is going to be, well, the whole, for sure, is going to be the whole chapter 1. Okay, all the sections in the chapter 1, and we're gonna see next Wednesday. But probably I'm gonna include the first section in chapter 2. Right? It depends. We'll see next Wednesday.
With number 3, do you do the same thing with number 2, where you flip both of them, or no?
Nope,
Yeah,
because you're gonna
because
have a
then it
y
ends up
in the, yeah,
canceling it out.
y, yeah, y. y is going to be like in the numerator and also in the denominator, right? So it doesn't really help if you flip both sides. But
Yeah.
however, you can cross multiply. You know, if you have, you know, in
Okay.
general, if you have like a, you know, if you have like a 2/4 that's equal to half, right? So then you can say if you cross multiply, then 2 times 2 is equal to 1 times 4, right? So you can also cross multiply, and that
Okay.
will be equal. Mm-hmm.
Hey, Professor, do you think we should
Yes.
go over number 3 first, like
Number
1, 2,
3.
2? Yeah, 'cause
Yeah.
I'm just
Okay.
like confused,
Okay.
like with
Yeah.
the cross
Yeah. Okay.
multiplication.
Yeah. 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 So yeah, we have like 5 minutes. Okay. Yeah. So I'm gonna go over number 3 first. Okay. Here's number 3. Okay, so my f of x, 5 minus x plus 1. So first step, I replace f of x by y. So here's my y equal to 5 minus x over x plus 1. Now we are to interchange x and y. So y becomes x. And so we have 5 minus an x becomes y, right? So here's y over y plus 1, right? This is plus 1 here. All right, so now I have to solve for y. Okay, so you see the right side is a fraction, right? A good idea is to make the left side look like a fraction. So what I'm gonna do, I'm gonna divide the x here, this is x, oops, this is x over 1. All right, so x over 1 is x, right? It doesn't change anything when you divide by 1. Okay, now both sides are fractions. I have y in the top, and I have y in the numerator and y in the denominator. So the thing what we can do here is we can cross multiply. So when you cross multiply, so when you have 2 equal fractions, then when you cross multiply, then it will be equal. So here, if you cross multiply, so then x times y plus 1 is going to be equal to 1 times the 5 minus y. Okay, so this is like a general fact. You know, this is like it's a rule. You know, if you have like A over B equal to C over D, all right, then when you cross multiply, then the AD would be equal to the B times C. All right, A times D would be equal to B or times C. So this is like a general rule. All right, so now, okay, now let's just distribute. So here I have X, Y, plus X times 1. And on the right side, I have 1 times 5. So that's 5 minus 1 times Y, it's just Y, right? So what I'm going to do, I want to solve for Y, right? So I'm going to move all the Y's, let's say, to the left side. So I have a Y here, and I have another Y on the right side. So I'm going to move this this one here, the minus Y, to the right, to the left side. So I'm going to add plus Y here. This is plus Y. So now it's X, Y. Okay, so it's X, Y, plus Y, plus X. And then this is minus Y plus Y. And then, so it's equal to 5. Right, so now I have all the Y's on the same side. That's good. Now I'm gonna move everything else to the right side. So there's this plus X in here. So I'm gonna subtract X. Okay, so now it's XY plus Y equal to 5 minus X. All right, so so why I'm doing this? It's because once you have all the Y's on the same side, all right, on the left side, like here it's on the left side, you can factor out Y, because, you know, Y is a common factor. You see that here's this Y here and this Y here. So it's a common factor, so you can factor out Y, right? So now I can factor out Y. So it's gonna be like Y and then times, and then here I have X, so it's X in here. There's a plus, so I'm gonna have plus here, and there's Y. So it's gonna be Y times 1, right? Y times 1 is Y, equal to 5 minus X, right? So you see why I move the Y's on the same side, because then I can factor out the Y. So now, once you factor out the Y, you can divide, you can divide, I have this Y times, you know, X plus 1, I can divide here by X plus 1, and here by X plus 1. So then this X plus 1 in the top cancel out with the 1 in the bottom, right? So it's just now Y on the left side. So it's, so the answer, so this is Y times 1. So it's just Y equals to 5 minus X over X plus 1. Okay, so that would be the inverse function. So that's F inverse. It's 5 minus X over X plus 1. So yeah, so you see how it works, guys. I mean, if you have fractions, you can cross multiply. That'll be, so it's gonna be equal. Then you move all the Y's on the same side. So because then you can factor out your Y, and once you factor out your Y, then you're good to go, right? You can just divide by whatever you have with the Y, okay, and then you get your Y. Is there any question about this, how I got Y here?
No.
So it's, yeah, it's this, you need to know how to play with these fractions, you know, and yeah. Okay, this is number 3. Oh, okay, we don't have time for number 2. So what I'm gonna do, guys, I'm gonna stop here, and I will do number 2 and number 1 next time. All right, and next time would be Wednesday next week. Okay, so yeah, so let's stop here. Thank you, guys, and I will see you next week. All right. Bye. Thank you, guys.
Thank you, Professor.
Thank you.
Take care.
You. Take care. Stay safe.
Thank you, Professor.
Thank you, Richard. Thank you.
Professor, I have a question.
Yeah.
Since we don't have school on Monday,
Mm-hmm.
as a Monday schedule run on Tuesday or no?
No. So, I mean, we're supposed to follow Monday schedule on Wednesday.
Yes.
But I mean, we meet on Wednesday anyway. But I don't know if you have another class, let's say, on Monday, but you're supposed to have Monday schedule on next Wednesday.
Yes.
But I mean, we meet on Wednesday anyway. That's the thing. Yeah.
No problem.
All right. Thank you.
All right.
Thank you, guys. Take care.